Okay, so today the goal is to perform experiment 6, and what we are going to do is we are going to measure the change in pressure, the change in temperature, the volume, and the number of mole of a gas to determine the ideal gas constant. So the final goal is to determine the ideal gas constant, and we want to see how accurate and precise are our measuring of the ideal gas constant. The reaction that we're using to perform this experiment is the following. It's a single displacement reaction, hydrogen displacement specifically. Magnesium reacts with hydrochloric acid to give a magnesium chloride and hydrogen gas. So we're going to measure R using the hydrogen gas developed during the reaction. How do we perform these steps? So the first thing that we're going to do is we're going to measure the magnesium. You have it here. That has to be polished so that we remove all the magnesium oxide that will that will slow down the reaction of the magnesium with hydrochloric acid. And we are going to determine the mass of approximately 0.3 grams of polished magnesium using the analytical balance. Then we're going to place this polished magnesium into this Erlenmeyer flask. Let me erase this. There is a 125 milliliter Erlenmeyer flask that is capped with a septum to which there are attached two items, and I will explain you in a minute what they are. Make sure that when you close that septum, you place the septum on the Erlenmeyer flask, that the two gadgets are attached where there are the two holes. You see the two holes? Because one of the holes that you see up here is blocked. So if you put one of the two gadgets in here, your measurement won't work, and you won't be able to measure change in temperature and change in pressure. So you put in the Erlenmeyer flask, and then you prepare this setup. So the setup consists of this Erlenmeyer flask. You have a temperature sensor that you're going to put inside the water in contact with, as much as possible, with the flask, as close as possible to the Erlenmeyer flask. Try to make sure, if you can, it doesn't touch the wall. Okay, so you're going to place the magnesium inside the Erlenmeyer flask, and then you're going to prepare the setup as is shown in here. So you have an Erlenmeyer flask in which you're putting the magnesium. Then you have one sensor for the temperature that you're going to put inside the beaker. Then you have, and this is connected to the channel 2 of the LabQuest instrument. This is here, let me show you. And then you have a pressure sensor that is connected to channel 1. So what you're going to see is the measurement, the measurement of the pressure here and the temperature as you perform your experiment. Make sure that then you're going to fill a syringe with 5 milliliter hydrochloric acid, 1 molar. So make sure that the upper part of your plunger, the upper part is on the 5, not the lower part, because the plunger has a rubber part that's pretty thick, so you want to have the upper part of the plunger. of the plunger on the 5. Then place, so you collect the 5 milliliters, making sure that you don't have any bubbles. So flick it, lower it again, fill it up again, go a little bit over the 5 milliliter, flick it again. Go up to 5 milliliters, like that, and then place it, screw it on the stopper of the syringe. What you want to do is you want to make sure that these two items, the 5 milliliter syringe filled with hydrochloric acid and the sensor for the pressure, are in the two holes here, because the third hole is covered. And so if you put them in the wrong place, you're not going to be able to make your measurement. So you have your magnesium inside the flask. What you're going to do is you start recording, you equilibrate your system. So let me show you here. So once you have all your components set up, you stabilize the system and you record the initial pressure and the initial temperature of your system right here. These are your initial pressure, initial temperature. And then what you're going to do is open the valve here, push down the 5 milliliter, and then push immediately up the plunger of the syringe and close it. Why do we do that? Because we don't want to have extra gas into our container that will increase the pressure of our solution. Then you start to follow the change of pressure and you record P final, which is going to be your maximum pressure that you have recorded on the lab quest, T final, but the temperature shouldn't change. Then once you're done with this, you are completed the first run of the experiment, and you release the stopper here, and you repeat step 1. Let me show you here. Step 1 to step 7, at least 3 more times, or at least until you have 3 precise reading of the pressure, so they are within +1, 2 kilopascal. Okay? So if you don't have the first 3 runs that are within that range, you keep repeating. You saw is the process is very quick until you get 3 precise reading of the pressure value. The temperature shouldn't change. Now let's talk about the calculation that you're going to perform. So in order to determine R, we need the pressure, the volume, the number of moles of the gas, and the temperature. And we have here you have ×3 because you have to repeat this 3 times. Okay? So how do we determine the volume? Once you finish all your runs, what you're going to do is you're going to take the Erlenmeyer flask, you're going to fill it up with water all the way to the top. Okay? Let me remove it from here. Okay, you're going to fill it up all the way to the top. You're going to put the stopper, and you're going to determine what is the volume of water in the flask, which is equal to the volume of the gas that does occupy the flask during when the reaction is completed, using a graded cylinder. So you fill it up with water, you put the cap on top, the stopper on top, and then you pour the water into a graded cylinder so that you can measure exactly the volume of the water. In alternative, you can weight the amount of water, and because the density is equal to 1 gram per milliliter, you can measure the volume indirectly. The other thing that you're going to do is you're going to find what is the maximum pressure, P max. The pressure of the system from delta P, so P max minus P initial, and the same thing for the temperature. The temperature is going to be T final minus T initial. But the temperature, as we said that we shouldn't change. So you find the pressure, you plug it in here. So this is step B. Step A is determining the volume. Step C is determining the temperature. How do we determine the number of moles? So the number of moles that we are using are the moles of hydrogen gas. We obtain the number of moles of the hydrogen gas by looking at this equation. We know what is the mass of the magnesium. We calculate the moles of the magnesium. We use the mole ratio between the magnesium and the hydrogen in the reaction to figure out what are the moles of the hydrogen. At that point, we can plug in the number of moles of the hydrogen, and we repeat times 3 this calculation R. So we're going to have R1, R2, R3, our 3 best ideal gas constant, and we're going to report the average of R. We're going to calculate the accuracy, determine the accuracy and the precision of our determination of R. This is all we have to do for today.
This is trial 1 of experiment 6. So in this Erlenmeyer flask submerged in water, we have a small piece of magnesium, which weighs approximately 0.03 grams. So I'm going to attach a syringe that has approximately 5 milliliters of 1.0 molars of hydrochloric acid. Now we're going to record the initial pressure and temperature before adding the hydrochloric acid to this amount, to the appropriate number of significant figures. Okay, once that's recorded, we're going to add it. Okay. Now observe the readings and record the maximum pressure and temperature to the appropriate number of significant figures in the correct units. Okay, this is trial 2 of experiment 6. So we have another piece of magnesium inside the Erlenmeyer flask that weighs approximately 0.03 grams. We're going to attach the 5 milliliter hydrochloric acid syringe to the apparatus. Okay, now record the pressure and temperature to the appropriate number of significant figures in the correct units. After that, we're going to add the 5 milliliter hydrochloric acid. Now observe and record the maximum pressure and temperature in the correct number of significant figures to the correct units. This is trial 3 of experiment 6. So in this Erlenmeyer flask, we have another piece of magnesium strip that weighs approximately 0.03 grams. And we're going to attach a syringe that is filled with approximately 5 milliliters of 1.0 molars of hydrochloric acid. Now before we're going to add, we're going to record the initial pressure and temperature to the appropriate number of significant figures to the correct units. Once it's recorded, we're going to add the hydrochloric acid. Now observe and record to the correct number of significant figures of the pressure and temperature. So after this experiment, we're going to measure the volume of the Erlenmeyer flask. So first we filled it to the top with water. We're going to put a stopper there, showing that that's how much volume it occupies, the water. Okay, now we're just gonna put some in some graduated cylinders. This is cylinder 1, so read to the appropriate number of significant figures the final reading. This is graduated cylinder number 2, so read to the appropriate number of significant figures the final reading, and add this measurement to the first one to get the final volume of the Erlenmeyer flask.